So we're going to be condensing today, which is going the opposite direction. Now, I want to remind you that when we were expanding yesterday, we started with one logarithm and we ended up with many logarithms. As we are condensing, we are starting with many logarithms and we are going back down to one logarithm. Now, a lot of times the instructions will not say the word condense. It will say express as a single logarithm. So if it says express as a single logarithm, that's your clue that they're asking you to go down to one logarithm, or in other words, to condense. Okay? So yesterday we focused on this side of the equal sign. Today we're going to focus on this side of the equal sign. So if we see addition, we're going to condense it to what? Multiplication. If we see subtraction, we're going to condense it to... And if we see a number in front of a log, we're going to bump it back to become an exponent. Okay? And we have our same rules from yesterday over here. So let's look and see what we've got first. The first thing I always look for, well, let me step back for a minute. The last step in most of yesterday's stuff was what? Which rule did you use last in most of them? The power property. The last thing you did was bump those exponents to the front, right? When we're going the opposite direction, that's usually the first thing we're going to look for, is any exponents that need to be bumped back to the being exponents. Keep in mind, not all of these are fully expanded. For example, this right here is not a fully expanded expression, right? It could be expanded further, but since we're condensing, we don't really care. That just means they did one step for us, right? So I'm going to start here. Are there any exponents? Where would I find an exponent? If this is the expanded form, where would I look for one? I would look in front, right? Are there any exponents? No, so I don't need to worry about that. Once I don't have any exponents, I just really work from left to right. So I take these two at a time. They are connected by addition. So what would they condense to? Multiplication. That would give me log base 3 of 2 times 7. What is 2 times 7? 14. So if they're numbers, go ahead and multiply them. And then I haven't touched the plus log base 3 of m. So far, so good? What do you think I do next? I take these two and I condense them. And addition will condense to what? Multiplication. 14 times m is, and I have nothing else that I have not condensed. So that would be my fully condensed form. Easy? After you've done expanding, this should be pretty easy. All right. This one, do I have any exponents to deal with? Nope, nothing's in front, so I don't have to worry about that. I only have 2 logs, so this should be pretty quick. They're connected by subtraction, so what are they going to condense to? Division. So that's going to give me log base 12 of what's my numerator? Over. Now, I do want to verify that this fraction cannot be simplified, because if it can be simplified, I do need to simplify it. Can I reduce or simplify 3x over y? No. So I'm done right there. If it was 3x over 3y, yeah, I could do some simplifying, and I need to do that. But in this case, I couldn't. Okay? So far, so good? All right. Last one over here. Do I have any exponents? Yes. So I need to take this, and I need to bump it back to being an exponent. Now, let's talk about this for a minute. Because I can't just throw a 1/2 on there and do 8 times 1/2 and call it a day. Because this 1/2 applies to everything in the log, which means it's going to apply to both the 9 and the x to the 8th. Does that make sense? So I've crossed it out of the front. I need to apply that to both the 9. So that's going to look like log base 7 of 9 to the 1/2. And x to the what power? 8 times 1/2 is 4. Do you think I have anything left to do? Yeah, I have to figure out what 9 to the 1/2 is. What is a 1/2 exponent referring to? Square root, so the square root of 9 is, so I really have log base 7 of 3x to the 4th. Kind of sort of makes sense? Okay. So those were the rules individually, just like I did yesterday. Now let's try them in a problem that has more than one rule. So first thing, what do I look for again? Exponents. I've got one here. I've got one here. Do I have one here? No. So this would be log x cubed plus log 3 squared, right? Minus log 5y. And I take 2 at a time. These two give me what? Log x to the 3rd times 3 squared. What do you think I call that? How about 9x cubed? Yeah? Minus log 5y. And now I'm going to combine these two. What are they going to become? It's subtraction, so it's going to become what? Division. That gives me log, what's my numerator? 9x cubed over what? 5y. And then the last thing I want to check is, can I reduce that fraction at all? Is there anything that'll cancel? No. So I'm done there. I did have a question yesterday where I had a fraction and someone asked, can't we subtract the exponents? What's our rule for subtracting the exponents in a fraction? Like, why can't I subtract 3 minus 1 and combine those? They have to have the same base. If I have an x and a y, I can't do that. If it was an x and an x, absolutely, do that. But an x and a y, I can't do anything with. Okay? All right, this next one has all numbers, doesn't it? Okay, condensing all numbers ends up usually fairly clean. So let's see what we've got. Do I have any exponents? Which ones are my exponents? 1/3 and 2. We got to bump those back. So log base A of 27 to the 1/3 power plus log base A of 6 squared minus log base A of 144. So far, so good? What is 27 to the 1/3 power? So I really have log base A of 3 and 6 squared, 36, minus log base A of 144. So we take 2 at a time. Those two are connected by addition. What are they going to condense to? Multiplication. So I have 3 times 36 minus log base A of 144. What is 3 times 36? Do I need my calculator? 3 times 36, 108. Minus log base A of 144. All right, so I'm down to 2. They're connected by subtraction, so what are they going to become? Division. So I have log base A of 108 over 144. And do you think I can simplify that fraction? Yeah. So I'm going to end up with log base A of, let's see, 108 over 144 is 3/4. If you have, by the way, I just plugged in the fraction to equals there. If you have this kind of calculator, which is the one I loan out because I have the set over there, you would type in 108, use your fraction button, which is right here. It says A, B over C. Do that. It makes a little kind of angle type thing, little right angle there. 108 over 144, and if I hit enter, it reduces it for me. Okay, and that's my answer there. So far, so good? Yeah? All right, last one here. This one's different. What's different about this one? It has natural logs. Do you see that? ln instead of log. Does that change anything? No, natural logs follow all the exact same rules. The only difference is you're writing ln instead of log. So, what am I looking for first? Exponents. Do I have any exponents? What have I got? A 3 and a 4. So I'm going to bump that guy up there. I have to be careful about this one. Why do I have to be careful about this one? Because there's a 2. So that 4 is not just going to go at the end, it's going to have to be applied to that 2 also. So let's see what that gives me. That gives me ln of 48 minus ln of b plus 2 cubed plus ln of, can I call this 2 to the 4th? Are you okay with that? And b plus 2 to the 4th, both of them get the 4th power. Does that make sense? Okay. Now, should I deal with these exponents on these parentheses? Does that become what? B cubed plus 8? No. Because to cube something like this, I have to write b plus 2 and then b plus 2 again and then b plus 2 again, and I have to FOIL that madness out. So I'm going to leave the exponents here for now, and let's see what happens. Okay. So let's see. I'm going to take these 2 at a time. Those 2 are connected by subtraction, which means they're going to become what? So that gives me ln of 48 over b plus 2 cubed. And then plus ln, what is 2 to the 4th? 2, 4, 8, 16 times b plus 2 to the 4th. You okay with this so far? All right, I have addition. It's going to condense to what? Multiplication. So that means I have ln, and I need to multiply this by this. Right? How do I multiply a fraction by something that's not a fraction? Well, this is technically over 1, correct? So that gives me 48 over b plus 2 cubed times 16 b plus 2 to the 4th over 1. How do I multiply something like that? If it's already factored, do you remember this from Mod 9? There's nothing I can factor, right? It's already factored because it's got those parentheses. I just make one giant fraction, and I can start canceling stuff, can't I? Yes? What can cancel? If I have 3 b plus 2's down here and 4 up here, then 3 of these are going to cancel 3 of those and leave me with just a plain old b plus 2 on top, right? So that's going to leave me with the natural log of 48 times 16 is 768 times b plus 2, and I don't need a denominator, do I? Because it's just 1. Don't worry about distributing anything. Just leave your answer like that. Does that make sense? Kind of crazy? All right. Your homework is worksheet 16.1b on condensing logarithms.